Hello guys, we will work today on our 1.7 notes and its right triangle application. For each problem, my goal is to draw a nice diagram or picture that can easily be interpreted to help me solve this problem. First problem says a ship is passing a lighthouse. Notice that I already drew my ship, and at its closest point to the lighthouse is located here. The radar determined that the ship is 2,400 meters. So this distance is 2,400 meters. And the ship continues on its path, and the next measurement is 2,650 meters from the lighthouse. So this next measurement is 2,650. And of course, it's from the lighthouse. So this distance is 2,650 meter, and this distance is 2,400 meters. Now, they require me to find by what angle did the ship's bearing from the lighthouse change, meaning from the original position to the next position, what angle is it making? So let's go ahead and call this angle angle theta. The only thing that theta, the only relation that theta has with these two sides might be given through a trig function. For this angle, this side represents my adjacent. This is the adjacent and this is the hypotenuse. So the only trig function that can be used here is the cosine. So I will say cosine of theta is equal to my adjacent, which is 2,400, divided by 2,650. Since this is a calculator portion, I wouldn't bother to try to simplify. My goal is to find theta. So I will say theta is equal to, because I'm looking for the angle, I will say cosine inverse of 2,400 over 2,650. Your calculator can help you determine this value, and if you use your calculator properly in degrees, you should get approximately 25 degrees. Keep in mind, we're rounding all angles to the nearest degree and all measurement to the nearest thousand. Let's go ahead and work with B. B says, how far did the ship travel between the two measurements? In other words, I'm looking for this dotted line. Why not call it X? To find X, I have multiple ways. I can use the Pythagorean theorem, which is by far the easiest one, or I can use either the sine or the tangent of angle theta. But because we kind of approximate angle theta, I'll be reluctant using angle theta again to find a missing side. So let's go ahead and use Pythagorean theorem. So I will say 2,650 squared is equal to 2,400 squared plus x squared. In other words, x is equal to the square root of 2,650 squared minus 2,400 squared. I'm using my Pythagorean theorem. And if you compute it correctly, you should get approximately 1123.610 meters. 1123.610 meters. Let's go ahead and work on the second problem. The second problem this time says a person on the edge of a canal observes a lamppost on the other side with the angle of elevation of 12 degrees. Keep in mind, the angle of elevation and angle of depression are always with the horizontal. So it will never be with the vertical. Apparently one of them is 12, the angle of elevation, depression is 7. This distance, the man's height is 152, and that's identical to this distance. So I will call this distance as well 100, and this distance is also 152. Now, I will call the remaining distance there, which is from the peak to this point. I will call it for now, why not call it y? Now, the first thing that we're looking for is the width of the canal. The width of the canal, I will call it x, and it is nothing other than this horizontal distance. I will highlight it from this point all the way till this point. That's what we'll be looking for. Now, to find that distance, I can use either. I have to use the bottom triangle. How? The bottom triangle has all the information needed to find the tangent. Since we don't have the hypotenuse, I would say the tangent of that angle, which is 7 degrees, is equal to opposite over adjacent. The only thing I don't know is x, so I will go ahead and find x and say x is equal to 152 divided by the tangent of 7 degrees. Keep in mind we're in degrees, and we get approximately 1237.941. Use your calculator to confirm these answers. Once we find x, the next question, this is for A, the next question says find the height of the lamppost. The height of the lamppost is this whole distance, and I will call it h. But this height is composed of 152 plus the distance that I currently call y. Let's go ahead and find y first, because if we get y, we can add it to 152 and get the total height. Y here, if I look in the triangle located on top, I will say y over x is equal to the tangent of 7 degrees or 12 degrees. So the tangent of this 12 degrees is opposite over adjacent. So if I want to find y, I will say y is equal to x times the tangent of 12 degrees. I just found x here, so I will take this value that I found for x and plug it in here to find the value of y, and it will give me approximately 263.132. But that's not it. To this value, I will go ahead and add the 152. I will add these two values, and it will give me the value of h. So h is equal to approximately, again, 415.132 centimeters. X also was in centimeters, by the way. Why centimeters? Because that's the unit that we started with. Let's go ahead and look at the next problem. Next problem, I started by drawing my picture. It says the swimming pool is 3 feet deep. This is my swimming pool. And since it's 3 feet deep, I understand that this distance is 3. And if this is 3, this distance also is 3. Just this portion is 3. Now, the bottom of the pool has a steady downward drop of 12 degrees. In other words, this angle is 12 degrees. That's your angle, our angle of depression. If the pool is 50 feet long, the length is 50. What we're looking for here is how deep is the deep end. In other words, we want to find out first this x, then we will find the whole deep or the whole depth of the pool. Now let's go ahead and find x. For this triangle located below the pool, I will use once again my tangent and say tangent of 12 degrees is equal to opposite over adjacent. So x alone is equal to 50 times the tangent of 12 degrees. And 50 times the tangent of 12 degrees will give you approximately 10.628. So this 10.628, I will go ahead and add 3 to say that the deep end is approximately 13.628 feet. This was a straightforward problem. Let's look at problem number 4 now. It says Penny stands 12 feet from a statue. Let's go ahead and say this is Penny. And she stands 12 feet away from a statue. So let's go ahead and say this is a statue. And we assume that the distance between Penny and the statue is 12 feet. Now, the angle of elevation from her eye, Penny's eye is somewhere by her face. So let's assume this is her eye. The angle of elevation from her eye, meaning from this point to this point, to the top of the statue. And if you're looking for elevation, of course, we need the horizontal. So I'm graphing my horizontal as well. Now, this angle of elevation apparently is equal to 30 degrees. So I'll go ahead and call this 30 degrees. But the angle of depression is 15 degrees. So I need to graph as well my angle of depression to the bottom. And this is 15 degrees. Now, the distance from this point to this point should be Penny's height. How tall is the statue? We don't know. That will be the whole height. So that's what we're looking for. He says, hey, don't forget the horizontal component of the angle of elevation and depression. And that horizontal component is what I'm highlighting now in green. Now, let's go ahead and find every single information that we might need. We know that this horizontal component is exactly 12 feet. Keep in mind this is in degree. We have 12 feet here. So I will use the small triangle, which is a triangle on the bottom. Using the tangent, I will say tangent of 15 degrees is equal to, let's call this x and let's call this y. Tangent of 15 degrees is equal to x over 12. So x is equal to 12 tangent 15 degrees. We can do the same thing in the triangle above, and we will say instead tangent of 30 degrees is equal to y over 12. In other words, y is equal to 12 tangent 30 degrees. Since the whole height is the composition of x and y, I will say the height is equal to x plus y, which is equal to, once you find the approximation of each, you will get the following values. X should be about 6.928 approximately. Y should be approximately 3.215, and if you combine them, you should get the height is 10.144 feet. I'll go ahead and touch on the last one since we still got some time. A 60-foot drawbridge is 24 feet above water. If it's 24 feet above water, it means that this distance is 24. The next thing I know is when open, the bridge makes a 33-degree angle with the horizontal. It's given there. And the whole bridge itself, from this point all the way to this point, is apparently 60 foot or 60 feet. Now we have a point P here and Q here. Now, if I ask you this question, what is the distance from this to this? You should be able to tell me that it should be exactly 60 feet as well, because that's where the bridge will close. So this distance is 60 as well. All right, just a second. All right, let's go ahead and figure out how high is the tip P of the open bridge above the water. So we want the distance above the water. So it's the distance from P all the way down to the water. But we cannot just find that whole distance. We have to break it down into two pieces. So the first thing is, I will stop at this yellow dot. In other words, I'm going from P to this yellow dot because I know the distance below from the horizontal line to the water is 24 feet. So sitting in this triangle, I will say, once again, using my tangent, I will say the tangent of the angle that is forming, which is 33 degrees, is equal to the opposite, which is the yellow part. Let's call it x for now. That'll be x over the hypotenuse, which is 60. So x itself is equal to 60 tangent 33. Is that correct? No. The tangent of 33 is equal to x over 60. That is not correct. If you can figure out what's wrong with it, good. If you didn't notice, I don't feel like giving y'all a mistake this time. I will write it as sine. Sine of 33 degrees, that's the opposite over the hypotenuse. So x is equal to 60 sine 33. And if you compute this, you will get an approximate value of 32.678. That's just the x value. Now, to this value, you will go ahead and add the 24. And if you add 24 to this, you get the distance of this pink line, and that is exactly 56.678 feet above water. All right, that's just for A, by the way. Let's look at B. B now says, when the bridge is open, what is the distance from P to Q? We're looking for this distance from P to Q, this small distance. In order for me to find this small distance, I need to figure out first what is the distance from this point to this point. If I can find this distance, I will take it away from 60. Keep in mind, this green line is 60. So if I find the distance that I'm making a dotted blue line now, I will be able to subtract it from 60 and get the distance from P to Q. Now, the distance that I just put as dotted blue will be given by the cosine of 33 degrees, which is equal to, let's call that distance y for now, is equal to y over 60. So y is equal to 60 cosine 33 degrees. And 60 cosine 33 degrees is approximately equal to 50.320. Double check this calculation. Now I will take this away from 60, so I will do 60 minus this distance, and the value that I should get is the distance between P and Q, and it will be approximately 9.650. Of course, that's in feet, and that's the distance from P to Q.